Okay, so I guess we can start. So hello once again on next lecture from the RS School program. My name is Paweł Waszczyński. You can find me on the Discord with this @waszczpa. And talk to me if you have any questions. And today's subject is pretty challenging. It's called Async JavaScript. So let's start. And also I just started recording, just to let you know. Okay, so what's the plan for today? So I'm quite a talkative person, so last time it took me 2 hours to talk about CSS Grid. So I hope today we're gonna finish before midnight. So in the beginning, I will try to explain the concurrency model of the JavaScript and basically how the browser works. Then we will talk about different techniques of organizing asynchronous code and dealing with asynchronicity in JavaScript. We will talk about callbacks, then promises, generators, async await, and finally at the end I will just briefly mention observables and arcjx because this topic on its own deserves at least a few hours of talking workshops and so on. So without talking too much, let's continue. And I was kidding about the midnight, so I will try to finish in about 90 minutes, so don't worry. So first thing, concurrency model. So there are usually 3 terms that you can find when talking about asynchronous JavaScript and basically about multi-threading programming. So it's parallel, concurrent, and asynchronous. So let me try to explain what does it mean. So first term is parallel. So in programming in general, we are talking about the true parallelism if we have multiple things happening at the same time. So for instance, we have a CPU that have multiple cores, and at the same time multiple threads can be executing your code and access the same variables. So it pretty much resembles the guy. So I used to play the guitar, so I was having troubles with synchronizing my both hands, and I always admire how guys were playing on the drums. So those guys seem to have like multiple cores in their brain. So one for one hand, second from the second hand, and so on. So this is more or less what parallel means. So at the same time, multiple things are happening or being processed. Then we have a concurrency. So the definition that I choose is concurrency. It means that 2 or more things are happening within the same time frame, and there is a dependency between them. So for instance, in the browser, you can start scrolling your page, but in the meantime, some other things might happen, like AJAX requests over the network might finish. So the browser works by just switching context between those different tasks. So it just gives you the perception that things are happening in parallel, but in reality, it's just like with the coffee machine on the top of the image. So basically there is one coffee machine and there are 2 queues, and only one person can go to the one coffee machine. Whereas the parallel means we would have like 2 coffee machines. So obviously the things will happen faster. And the last thing, it's async, so asynchronous. And for me, and the definition that I choose is asynchronous means that something will happen at unknown, unpredictable time in the future. So when we are talking about the code, about programming, so it means that some code will be executed at unknown or unpredictable time in the future. So we can have synchronous code. So probably this is more or less something that you have been doing so far. So you had some lines of code, and each line of code must finish, must have been done before the execution of the next line starts. So this is synchronous code. But also in JavaScript, we have asynchronous code. And what does it mean? So given that we have some lines of code, one line of code can schedule some work to be done in the future. What happens next? So the first line schedules the work, and it can proceed to the next line without waiting for the previously scheduled task to finish. And at some time in the future, the scheduled work is done and it can be processed. So the analogy that I found, it's something similar to being in a restaurant. So the waiter is collecting the orders from the client, and once the food is ready, the client will get an order. And because some food takes less time to prepare, other more, the order of delivering the meals doesn't need to necessarily be the same as collecting the orders. So for instance, then there can be a client that came after me to the restaurant, but he or she will receive her order first because like making a soup takes less time than making a delicious spaghetti, for instance. So JavaScript is like a restaurant with a single worker that works as a waiter and also as a chef. So that single worker has to switch between tasks. So when the new client arrives to the restaurant, it has to collect the order. Then he needs to go to the kitchen and check whether everything is fine with the preparing of the meals. If everything is fine, he checks if some meals can be delivered. So if something was already done, if it's done, then it gives the meal to the client, and so on and so on. So it's like a one-man show. And this is how it's being done in the JavaScript, more or less. So yeah, so forgetting about this analogy, so the missing piece of the puzzle is we can schedule this asynchronous work to be executed, and it's going to be finished sometime in the future. But we need a way to be notified when the scheduled job was done. And the most basic primitive in the JavaScript for that purpose is callback. So we will discuss callbacks more deeply in a few slides, but before continuing, I want to make sure that you know what a callback is. So callback is just a function passed as an argument to another code, and this callback is expected to be called at a later time. So probably so far you have been using callbacks when doing some functional programming stuff. So for instance, here we have a map function that accepts a callback. And this callback is going to be executed for each element in the array. So this is totally synchronous. So we know that when we call map on the array, the JavaScript will just iterate over the array and pass each items from the array into the callback function. With asynchronous code, it's different. So here is maybe not the simplest, but one of the simplest examples of asynchronous code. So Browser has this API which is called setTimeout. This is function provided by the browser, and this function also accepts a callback. And in this example, we have a callback that will be executed after 2 seconds. This digit 2000 is, it means that we want to execute the function after 2 seconds. So this is one example of callback. And another one that you might already been doing is asynchronous callback to a button click event. So in line number 6, we are getting the element from the DOM, and on element 7, we are subscribing to this event. So we say that when the click happens on this element, we want to execute function, a callback function, and this callback function is react to click. So we are just waiting for the click to happen. Okay, so what's next? Async JavaScript fundamentals. So I took a quote from the MDN documentation site. So the first sentence says that JavaScript's concurrency model is quite different from models in other languages like C and JavaScript, or C or Java or C#. And from my experience, and also I was one of those developers, the reality is that JavaScript popularity is increasing. This language is very easy to use. You don't need compiler. You just write a few pieces of code and it just magically works. So sometimes developer, and I was one of them long time ago, just come from other languages and they make assumptions about how JavaScript works from other languages. So they don't dive deep into the understanding how the browser works. And nowadays it's even more convenient to use just frameworks like React, Angular, and just to ignore the fundamentals. Personally, I remember myself being interviewed a long time ago, and one of the first questions I was being asked was, is JavaScript multi-threaded? And I quite frankly didn't know the answer because I was just doing my job on a daily basis and I just wasn't interested in the fundamentals. So that struck me at that time. But the good news is that the concurrency model that we are going to explore is pretty simple and easy. What is complex is writing the code. So the fundamentals. So JavaScript is a so it's answering the question from the interview that I had a long time ago. So JavaScript is a single-threaded programming language, and what it means that it has a single call stack, and 2 or more bits of script cannot run at the same time. They have to run one after another. So just in layman's terms, it means that in JavaScript, there can be only one thing can be executed at a time. And JavaScript's concurrency model is based on something which is called event loop. So that means there is a queue and that receives events or messages, whatever you name it, to process. And this is first in, first out a queue, and basically every event that it's being generated goes to that queue at the end of the queue, and it's waiting for being processed. So on the image you can see like there is a V8 engine. Web API is just a block that describes different kind of APIs that the browser has and can generate events. So those events go into the queue. Then the even loop is checking whether the queue is empty. If it's not empty, it's taking the one item from the queue and it puts it into the execution engine. So, and the code starts running. So there is yet another quote from this one is from Node.js home site. So Node.js is a like a runtime environment for backend applications in a nutshell. So it says that Node.js uses an event-driven non-blocking I/O model that makes it lightweight and efficient. So once again, what does it mean? So it boils down to the concurrency model and event loop working together. So like we said, JavaScript is single-threaded. So we have a call stack, a message queue, and a heap where all the allocated variables, objects, etc. live. So tasks are waiting in the queue. A queue is used by the even loop, and you can also find these terms like browser loop tick or event loop tick. So it means that basically it's a shorthand for one iteration of an even loop. So yeah, so basically, like I said, it's pretty simple. So the event loop has more or less one job. It's to do. The event loop is monitoring the call stack. So if there is still some code being executed on the call stack, it does nothing. But if the call stack is empty, it takes the first item from the queue and it throws it on the call stack, which effectively runs the code. So pretty simple stuff. So another important notion to get familiar with async JavaScript is a term called run to completion. So what it means, in a JavaScript, when a chunk of code runs, it has to run to completion. So more or less, it means that when you have a long-running operation with multiple nested functions being called, so function A, then function B, and so on and so on, at no point of time, no other piece of code can be executed and can just jump in the middle of your work. So to put it simply, no other piece of code can be executed until the call stack is empty. So it also, to rephrase it, no chunk of code can be preempted. So this is like a term I got familiar with when working with the C# code. So in order to demonstrate it, let's have a look at code example. So let's say there is a web service which is generating a random numbers. So we are using the fetch API. Basically, this function just executes an AJAX request and gets the response. So usually calling this API takes a few milliseconds. So if we just execute the code, yeah, so once again, something goes wrong. Yeah, so you see, the request was done. If we would open the network tab, we will see the AJAX request, and within the, I don't know, a few milliseconds, we see console log statement request was done. So that's a proof that this API is blazing fast. But if after making the request, we initiate the long-running operation. So in this case, the long-running operation just loops for 10 seconds. Let's make it shorter. So if we initiate this kind of long JavaScript running job, we will see that even though, the REPL is, I guess, smart enough to block my code. That's interesting. It used to work before the presentation. Try once again. Yeah, so potentially infinite loop. So this environment is pretty clever. So basically, we would see that this console log statement would be printed after 5 seconds because this JavaScript code is running and it cannot be preempted. So nobody can jump in the middle of execution of this code. So even though the AJAX request was done pretty quickly, it has to wait until nothing is on the call stack. Okay. So yeah, so that was really artificial example. So let's have a look at something that has to do with the browser and making changes that are visible to the user. I just hope this time just Planker won't disappoint me. Okay, so we have a simple page with a button that says click me to change the page. So let's see what's going on. So we get the button, we subscribe to the event listener, to the click event with add event listener. And what we are actually doing is we just changing the background color of the body to red, and we are changing the text. So let's see if it works. Let's refresh. Yeah, so background color got changed, text got changed. But the same thing like in the previous example, if after executing this code that wants to change the color, we start doing some heavy JavaScript work, which is iterating inside the while loop for 5 seconds. We can see that nothing is happening. So even though we change the properties of the document, the browser just simply has to wait until the JavaScript code finishes before processing with other tasks. So the example that I showed on Planker, so a few times I saw people that they were blaming like long AJAX requests or other asynchronous work for freezing the UI, but indeed it's only JavaScript that can do that. So the bottom line is avoid blocking and long-running code that will hog the CPU. So if you write a JavaScript, try to do things quickly. Okay, what's next? So you might wonder, looking at the previous example, so why you were setting background color of a body and it just didn't got updated. It just has to wait. It had to wait for the JavaScript to end. So in browsers, JavaScript code execution shares this single thread with a load of other stuff that live inside the browser. So this other stuff is usually garbage collector and engine responsible for style and layout changes. So this is why, for instance, if you have a memory leaks and garbage collector kicks in very often, you might see that, for instance, animation freeze on your site. And the same thing happens if you have long-running JavaScript, then you won't see the animations happening, for instance. but there's a hint for that. So there are plenty of CSS features, probably you know some of them, like animation frames, transitions. They are not being processed by the style and layout engine. They are using the graphical processing unit. So that's the one hint. But the bottom line is that this single thread has to do plenty of things. So try to write your JavaScript quick. Yeah, so like I said, activity, if one of these things like layout engine, garbage collection blocks the other, and the other has to wait. One thing to remember, so don't get it wrong. So browser has many threads, but when we are talking about the single-threaded JavaScript, we are talking only about the JavaScript code that we are writing and we are executing. So under the hood, the browser can spin up many threads for different purposes. So this whole asynchronous model and this whole concurrency model of JavaScript is pretty simple. So there are some pros. So we don't have to deal with a bunch of multi-threaded synchronization techniques like in other languages that are multi-threaded. So we don't have things like semaphores, signals, matexes, and you name it. It's just they don't exist because we don't have any race conditions and so on. So now we know that JavaScript is single-threaded and we have asynchronous code inside the JavaScript and concurrency model that uses events that are being processed by event loop. So we need to learn about the sources of asynchronism or events in the browser. So there are many of them. First of all, most important probably is UI interactions. So all kind of DOM events. So there are plenty of them, like clicking, mouse moves, keyboard, key up, key down, key press, touching on your mobile devices, resizing the window, scrolling the window. All those activities are generating DOM events, and they are putting things into the event queue. So like we saw on the previous example with the button, so if a user clicked a button and there was a callback registered, so it's going to be enqueued. If there was no callback registered, nothing would happen. So once the event loop is processing the event from the queue, all the listeners are fired synchronously. So for instance, if we have a button with at event listener called multiple times in different places of application, we will have multiple callbacks registered, and they all will be fired synchronously in the order of registration. There are some edge cases. I won't talk about them too much, but if you like, you can check those links. So some time ago, I had some issues with some events like focus. There are some really edge cases in the old browsers that just break the rule of single-threaded JavaScript, but it's just, if you have some spare time, just give it a read. So another sources of asynchronism is timers and intervals. So set timeout, this is a function that you already saw. So basically it runs the code after the delay. Set interval is pretty similar, but it runs the code at specified intervals. So like for instance, every 2 seconds. Delay argument. specifies when the job will be added to the queue. And usually, last time I checked, if you make a delay smaller than 4 milliseconds, the browser will simply override it. And if at the moment of adding element message to the queue is empty, the code will execute straight away. Otherwise, it has to wait. And the thing to remember is that delay is minimal time that the code has to wait. It could be longer. So, for example, let's recall this rule, run to completion. So it also applies to timers. So if there is a long-running operation and the time for the timeout elapsed, there's no way to execute it, so it needs to wait in a queue. So to demonstrate it, let's have a look at the REPL once again. I wonder whether it will spot what I'm going to do or not. So in the first line, we are using the set timeout API, and we are saying let's execute this callback function after 0 milliseconds, so basically straight away. But a few lines after that, we are just looping once again for 10 seconds and just hogging the CPU. Yeah, and once again, the REPL just didn't allow me to do that. That's interesting. So maybe let's do a Node.js. The previous one was using Bubble, so let's see. Yeah, and that one is working. Interesting. So as you can see, so this loop is just looping, and every 1 second we see the console log. And after 10 seconds, we see that done callback was executed. So even though we just told the browser, hey, execute it after 0 milliseconds. So if you just comment that code out and run it once again, we see that done was completed once again. So this is once again the proof that you shouldn't be writing long-running JavaScript because it can just prevent other code from running. Another sources of asynchronism. So web workers. The definition is pretty weird. Excuse me. So a web worker is a cross-origin iframe. Basically, this is a mechanism in the browser that has its own stack, heap, and message queue. So it's like a completely separate, let's call it, environment inside the browser. So as you saw, it is possible to write code that is blocking the user interface from responding, but sometimes we have to do it. We should avoid it, but sometimes we have to do it, like, I don't know, sorting some kind of huge array, I don't know. So the solution for this case is using web workers. So if you have this long-running job, you can create a web worker, and basically this web worker will process this long-running task, and that can take, I don't know, a few seconds, for instance. And the web worker has an API called post message, and this API can be used to communicate between your main application thread or even loop and between the web worker. So this is, and why I mentioned it as a source of events, this is because you can have a different web worker. You can have many web workers that will communicate with your event loop via messages. So this is still a source of events. And an example, once again, on the planker. So we have a page with a progress bar, so you can see that the progress bar is slowly, but every second it increases by 10%. So how does it work? So let's go to the background JS. So this initial example works like this. So you create a web worker and you specify a script that should be doing long-running operation. And then you say when this web worker posts a message, I want to subscribe to it with this callback message, and I will receive the message. And basically what I'm doing is I'm just overriding the progress. This is why the progress bar was animating. And this crunch numbers JS function, well, surprise, surprise, it's just iterating over and over for 10 seconds, and every 1 second it just calls the progress callback, and basically it posts the message to the background JS event loop environment. So once again, if we are having a web worker with long-running operation, it will not block our user interface. But if we switch to the script which is called inline.js, and we will do exactly the same thing, but without a web worker, let's see what will happen. So totally blank screen. So for 10 seconds, we don't see the initial document and we don't see the progress bar animating. So if you are patient enough, and we will wait for 10 seconds, yeah, we should see the progress bar, but only after all the work is completed. So the bottom line, web workers, use them to delegate long-running operations, and web workers can communicate with your main event loop via messages as well. So basically, there are countless numbers of there is a countless number of sources of events. So there can be a network I/O, so fetch API, which was not so long ago introduced to JavaScript. Mostly on Node.js, you deal a lot with the streams and files. So those are also sources of events. And if you want to have a look at the number of them, see the Mozilla developer documentation. So basically the list is pretty long. Yeah, basically you can find events almost for everything, even like device orientation. So if you hold your mobile phone and you change the orientation, you can subscribe to this kind of events. Battery events, so when the battery starts charging. So basically, if you ever need some kind of event, just go here, Control F, and try to find it. There's a good chance you will find it. Also, there are plenty of interesting APIs that you can use on a daily basis. So I just wanted to mention 4 of them. So request idle callback. So this is yet another alternative way to web workers to do long-running operations. So basically this API allows you to execute a work when the browser tells you that, hey, I have some free time, so you can proceed with your long-running operation. So, of course, your long-running operation must support like suspending and resuming, but this is one of the options. Then you can use request animation frame. If you register a callback to this API, you will get notification just before the browser starts repeating. It's pretty useful when doing animations. Also intersection observer, so you can tell the browser that you want to watch for changes in the DOM structure, like adding child elements, or you want to observe changes in attributes like style, classes, etc. So you don't have to do it inside, for instance, set interval. So you can just subscribe and the browser will automatically notify you when something happens. And there is a mutation observer API, which is yeah, so sorry, I just was talking about mutation observer before. Yeah, so basically mutation observer is about changes in the DOM tree, and intersection observer is about watching the positions of elements in the viewport. So it's very useful when you want to see if the element is visible on the viewport. So it's pretty useful technique nowadays. For instance, when you want to load the images when they appear in the viewport. So read about those APIs. So hello world example. So once again, to summarize, so for instance, set timeout is an asynchronous function. It schedules a job after a time delay, which is the second argument. So to make it clear, line number 2, which is console log hello, will be executed first. Line number 10, which is hello again, will be executed second. And even though line number 6 is in the middle, it's going to be executed as the last one after 2 seconds. So this was like a fundamental introduction. So this concurrency model is pretty simple, but the asynchronous code needs to be structured in a slightly different way, and there are different patterns for dealing with concurrency and asynchronous code. And this is what we will focus on the next slides. And we will talk about callbacks, which is like a most basic thing. And then we talk about promises, async await functions, generators, and reactive programming. So the first way to organize and deal with asynchronous code is callbacks. So yeah, the definition, I think we already talked about it on some slides before. So it's just a regular function, and you can pass this function to an asynchronous API. But apart from being like a simple, so callbacks are manageable and easy to understand if there is one source of asynchronism. And they are also a good choice if you have a stream of events, so like button clicks, mouse moves, etc. This approach in the long run and in more complex scenarios has only disadvantages. So those advantages summarize under the term which is called callback hell, or sometimes pyramid of doom. So, and basically it happens when next task depends on the result of the previous, and we are using the callback pattern. So on this code snippet, you can see that we have first function. It receives a callback function. Then when the first asynchronous action is completed, we execute the second one, get more data, and we can just nest it and nest it and nest it. So at first glance, you can say that, oh, it looks ugly, there's indentation, it's hard to read, but the callback hell is actually a lot more than many levels of nesting and indentation. So one of those additional issues is lack of trust. So basically, we are passing a callback function to some other code, and we completely don't have a control over when it's gonna be called. We cannot be 100% certain how many times it's gonna be called, if it's gonna be called synchronously or asynchronously. So basically, there is a lack of trust. And also, it's hardly impossible to write a code that is synchronizing two asynchronous, well, two, it would be even manageable, but more than two asynchronous operations. So let's imagine you have one AJAX request and a second one, and you want to do something when both complete, but they can complete at a different time. So with using a callback, even for two asynchronous operations, it becomes really, really complex. And I will show you like really popular example. So fetching a weather forecast. So we are in Krakow, so we can see forecast for today and 5 days forecast. So what this code is doing is we are using the raw AJAX request API, which is called XML HTTP request. We are registering the callbacks. And once the first operation succeeds, we call 5-day success. And when the today's weather forecast succeeds, we call the weather success function. And in the end, we append the results to the body. So everything will work fine, provided that we get the response from the first AJAX request first, from the current weather forecast first, and the 5-day forecast will happen in the second. But like this is internet, right? So even though we are doing so basically, usually, if we will do this request first, it will become resolved first, but the order can change. So for instance, let's have a look what will happen if we will simulate a delay in the second. So let's make it 5 second timeout. So there's a situation. So we are receiving the 5-day forecast first, and then we are receiving the current weather second. So the code, because it was assuming that the current weather forecast was being provided first, it was just clearing the document, and the 5-day forecast that was fetched first, it just disappears. And just believe me, writing a code that will try to resolve that issue will be complex. So we would need some shared variables. So when we receive the 5-day forecast first, we would need to store it in some temporary variable and reuse it when we get the current weather forecast. So it will become a really unmaintainable, and this is only for two asynchronous operations. Yet another issue with callbacks, with callback hell. So what if we want to register multiple callbacks? So basically, usually there is no way to do that. Another issue is it's very hard to implement consistent and maintainable error handling logic. So on the right hand side, you can see some, yeah, it's really hard to read. Some callbacks. And usually there is a pattern that if you have a callback, it will receive an error as a first argument. So you always have to check whether this variable is set. So for instance, in line 4, we are checking if we are having a parse error, then we are doing something. Otherwise, we are still going down and down and down. So it quickly becomes unmaintainable. And also reusing the error handling logic is really hard. Another two issues with callback hell is that we are having a producer and consumer in the same place. So if we have this API that is based on callbacks, the producer, which is, for instance, make Ajax call function, has to be in the same way where the callback. So it's tightly coupled. So we cannot like initiate the Ajax call and decide to do something with it later. So it's really tightly coupled. It has to be in the one place. Yeah, and if we want to get around the previous thing that I said, that we have a callback in the same place as the producer, so we can, of course, pass around the callback, which is a function, deeper and deeper and deeper, but it still creates an issue. So the solution is to use to majority of those issues is using a promises or async await and other patterns. And also just one thing that sometimes happens when people are using callbacks and asynchronous APIs. So it's a trap when you are using closures. So remember that asynchronous code will execute in the future. So there are a lot of bugs. So maybe nowadays less because we have a let and const keyword. But previously, if you have an asynchronous API and passing a callback, remember that a closure is being created and you can access, and basically the closure accesses the variables that are outside of the callback function. So for instance, here in this example, even though it might seem that every iteration of the function will schedule a timeout and you will see 1 second elapsed, 2 seconds elapsed, 3 seconds elapsed, basically it will print free all the time because you are closing over the I variable, which is set to free at the end of the timeouts. So solutions use the let keyword or the const keyword, use the ify pattern that will create a copy of the variable, or just create a separate functions. Basically, it's almost the same like with the ify. So you have a separate function that just copies the number in our case. So just remember about that. So entering promises. So I was just looking for a meme and I just realized somebody already created that. So I guess promises can be confusing. So the simple definition. So before I will show you some code, I will try to explain what a promise is, and then we will see some code. So a promise is a promise represents a single asynchronous operation that hasn't completed yet, but is expected to complete in the future. So you can think of a promise as a container for future value. So when the promise receives the value, so asynchronous action will complete, we say that the promise is resolved. And when something goes wrong, the promise is cancelled or rejected. So in all of those cases, the listeners, so somebody that is interested in the promise result, will be notified. In JavaScript, a promise is a built-in object. It's a built-in type representing a value. It has a native support. I checked yesterday, it's like a 95%, but in reality, with polyfill, it's 100%. So you can use it safely in JavaScript applications. Promises are not unique to JavaScript. So if you are coming from other languages, you can see, you have used promises under different names. So in C# we have tasks, in Java futures, and also in different libraries or frameworks, promises existed for a very long time, but under a different name. So in jQuery we had deferreds, in Angular there was a queue service, and there were plenty of JavaScript libraries like Bluebird that implemented this concept. So that's the promise. So simply a container for future value. So promise follows strict rules, and we can be 100% those rules will be followed because the promise is built into the browser. So it solves the issue with callbacks that we had, that we were relying on assumptions, right? That somebody will call our callback only once. The promise is a promise, and it has to follow these rules. Okay, so promise manages some state inside inside and abstracts the time issues in a wrapper object. So rule number 1, a promise can only succeed or fail once, so it cannot succeed twice or more times. So that's the rule number 1, and it also cannot switch from the failure state to the success state and vice versa. If a promise has succeeded or failed at a later, and you later add a callback, then the callback still will be called, even though the promise resolution happened before. So it's quite different from the callbacks approach that we had. So for instance, when you had a button and you registered to button clicks after the fact that somebody was clicking on the button, you didn't get notifications. So with promises, it's opposite. So you can create a promise, some action will start, it's going to be processed, the promise will resolve. And if you subscribe to this result later, you will still get notification about the result. Yeah, so basically that's more or less what I said, the difference between events and promises. Another important rule, once resolved, the promise is immutable. So you can pass it around and nobody can modify it. So this is, for instance, important in functional programming. Another rule, basically it's maybe not a rule, but a feature. So promise gives you the ability to separate initialization of the operation from registering the callbacks. So this is one of the drawbacks of that was mentioned on the callback health slide. So basically we had a asynchronous API and the callback in one place. With promise, it doesn't have to be like this. So you can create a promise in one piece of your application, and because a promise is an object, you can use it somewhere else at a different time, and you can register callbacks later. So it gives you a nice separation of places where you initialize the work and where you subscribe to the result. And another rule, so promises are eager. So once you create a promise, it already starts the job. And that is what enables concurrency. And basically that's the feature maybe of the promise API. So it enables chaining, which we will have look in a few seconds. So usually when working with promises, we have like a really strict dictionary that everybody uses. So the promise can be fulfilled, rejected, pending, settled, and we also have a deniable. So pending, it means that you created a promise, for instance, an AJAX request, and it's still in the process. So you didn't receive the response from the server, so it's pending. If it's fulfilled, then it means that the operation resulted with a success. If it's rejected, it means that something went wrong. And the settled state is just a term that you use for either fulfilled or rejected state. And this is just the image that shows the state transitions. Yeah, so we go from the pending state to fulfilled or rejected, or there is one additional, like an intermediate state called locked in, because sometimes you can resolve a promise with another promise. So basically, you have to wait for the next promise resolution. So this state is called locked in. So we know the theory, so how to create a promise. So one way of creating a promise is with the constructor function. So we are using the new operator, promise constructor function, and this constructor function receives executor function. This is the name from the documentation that receives two arguments. One of them is the resolve function, and second is reject. And if you write your own promise, then, for instance, on the line 5, you can make some complex stuff, and based on the output of this of your operation in line 6, you can decide whether you want to resolve or reject the promise. So if you call the resolve, the promise will succeed and go into the fulfilled state. And if you call reject, it's gonna be it will go to the rejected state. And this is a simple example of wrapping our set timeout asynchronous API into the promise. So we just create a function after delay, we get the milliseconds delay, and we are returning a promise. So in our case, we don't need to reject because we assume that the set timeout will always succeed. So we just call the resolve after some delay. There is a term for it. It's called promisifying. So sometimes when you are dealing with an API that doesn't support promises, but you want to use promises, you can write this kind of wrappers on your own, and it's called promisifying. Another ways of creating promise are using static methods like promise resolve or reject. So here, yeah, so we have just a function, and once again we have an if statement, and we are creating a promise that is resolved or rejected with a static value. So those static functions create already settled promise. However, you need to remember about a few things. Even though this whole operation of this function gimme promise is not asynchronous, promises reject or resolve callbacks will run asynchronously. So they will run on the next tick of the browser. So there are some micro and micro task queues, but I think that level of abstraction is enough. So even though it's synchronous, we are not doing any set timeouts, we are not doing internet request, AJAX request, it will still run asynchronously. So event loop is gonna be used under the hood, and run to completion rule will be executed. So it means that currently running JavaScript code must be totally finished, so nothing must be on the call stack before the callbacks for the promise are executed. So that resolves another issue that was mentioned on the callback health slide, that sometimes we didn't know whether the callback will be really asynchronous or synchronous. You might wonder why this is so important. So I will just give you one example. So let's say we have a short piece of code and we are starting an asynchronous operation, and inside the callback we are setting the name, the variable process status to done. So it means that we kicked off the operation, and once the callback is called, we set it to done. So we are assuming this thing is asynchronous, because in the next line we are setting the process status to in progress. So if we didn't rely on this rule that promises are always asynchronous, it could happen that that promise just did its work. It, like, I don't know, it just cached the result or something, and the callback is called synchronously. So it would call this function immediately, and then this thing next. So we will see the in progress in the console forever. So we wouldn't see done never. So this is important, that we can make an assumption that promises are always asynchronous and write our code with this assumption. So how are we dealing with the promise results? So there is a then function on a promise object, and there is a catch function. So the then is called when the promise succeeds, and the catch is called when something went wrong and the promise just failed. The catch function will be also called when there was an exception, so null pointer issues, etc. So this is like it just works like a regular try-catch block. So those are two functions that are used for handling the results. And also, yeah, so that's the code snippet that tells that we can register multiple times to the same promise. So, and once the promise resolves, it will call all the callbacks. So the next thing that we can do with promise is chaining. So sometimes we have multiple asynchronous operations happening one after another. So we can use the chaining. So what does it mean? So promise has a then and catch methods that can be called on initial promise. But those functions will always return yet another promise. So explicitly, so if you do a return statement, or implicitly, even if you don't return anything. So if you have a then callback with no return statement, still somewhere under the hood, the promise object will create a promise for you, and it will return it from the then. And those are the rules of what is happening when the chaining happens. So subsequent then functions receive a returned value. For instance, a returned value from the previous then. And this value can be static, or it can be another promise. So here's the example. So on line number 13, we are creating a promise from the function that we created earlier after delay. So when this promise fulfills, then we are returning another promise, and then we are using chaining. We are calling yet another then. In line 16, we are not returning anything because like that's the end of our chain. And on line 17, we are using the catch. So basically, the callback on line 16 under the hood, it will return a promise, but that promise will be fulfilled. So the catch function on the line 17 won't be called. But this is still chaining, right? So we have then, and catch. And there are a few other API functions on the API in the promise API. So there is a promise all. So basically, it takes an array of promises and creates a new promise that will fulfill when all promises that are arguments of the all function are successful. So let's have an example. So in lines 2, 3, 4, we are creating 3 promises with the fetch API, and we are interested in executing a callback once all of them are successful. There is one drawback with this approach. Okay, let me go back. So just when you will be using the promise all, just remember that you will always have to wait for all promises to succeed. So if our fetch to URL1 takes and URL2 are really quick, but URL3 is really slow, then you will have to wait with processing the results from fetch 1 and fetch 2 until the fetch 3 succeeds. So usually there is a better way to write this code, so you can initialize those actions like in lines 2, 3, 4, and then make a promise chain. So you still can process the results from the fetch API, but without waiting for the slowest one. An even fancier way you can do with the map and reduce. Those functions probably you already know from the previous lectures. So use this promise all with caution. Just remember that you will always have to wait for the slowest one promise to resolve. Promise raise. This is one of the useless APIs in the browser and basically that I ever Googled. The only use case that I found is that basically what it does. Maybe first thing. So basically, it also, just like promise all API, it accepts an array of promises, but it will take the first one promise and don't wait for the others. So the only use case that I found for it is making a timeout. So you give it 2 or more promises. One of them rejects after a timeout, like 2 seconds, and the first one is the regular promise. So if the rejection happens first, you don't wait for the other promises. So, but it exists on promise. Also, important thing about the promise API is how rejections happen. So, and what a rejection is. So basically, promise can be rejected, and it will happen when a promise is explicitly rejected. So you call the reject function, but also if an error was thrown in the executor function. So for instance, here we are trying to parse a string which is not a JSON, so it will definitely throw an error. So even though we didn't call the reject function, the catch will be called the catch callback will be executed. And the thing to remember about promises is that errors inside the promise are never lost or swallowed. So if you have a promise, it failed, you can subscribe with a catch at a later time, and the promise remembers that it was rejected, and it will give you a notification that something went wrong. So promise advantages. So it's more or less like a summary. So we have a separation of the code that handles the result. So handling logic can be set at any time in the future. So promise can resolve right now, and you can handle the result, I don't know, in a few seconds or at a later time. You can register unlimited callbacks. It's easy to write error handling code, which is consistent and reusable. But the thing that you cannot do in case of failure, you cannot easily retry a promise. You just need to create a new promise. We get a consistent async behavior, so callbacks will be called always asynchronously. And we don't need to write try catch because there is a then and catch functions on the promise. Okay, so when to use promises? Basically, like 3 years ago, I would say very often, always, except when you are dealing with stream of events. But since 2017, we have a new language feature, which is called async await functions. So nowadays, you will see promises being used less and less explicitly. But basically, this is a very good pattern for organizing your asynchronous code. So once again, comparison on the left-hand side, we have callback hell. On the right-hand side, apart from having more lines, that could probably, I could probably make this code snippet shorter with arrow functions. We can see that we have more or less async code, which is looking like a sequentially. So generators. So I think that doesn't matter. I think that this guy is crying even more on this slide. So let's proceed. So to summarize the promises, so they give us a nicer experience than the raw callbacks, but we are still bound to promise API. We have to use this then function. We have to use catch function. So there is this verbosity. So we have to write more code. So what would happen if we could turn the code which is on the left, which is promises, into code that looks something like on the right-hand side? So we have some magic keyword, I called it gimme. So we have line number 1. So the foo returns a promise. We prefix it with a magic keyword gimme, and it just resolves the promise and gives you the result. So it will happen automatically. So is it possible to do something like this? And the answer, of course, is yes. Initially, that was possible with generators and iterators. So in ECMAScript scripts, we were given something which was called iterators. So probably you already know about it from the previous lectures. So basically an iterator is an object that has a next method, and that method returns an object with a done and value properties. One example of iterable object is array. And if you pass an array to the for of loop, under the hood, the iterator is being involved. So this is believe me, like a simple iterator. So it will just generate numbers from 0 to 100 with a step of 1 as a default parameters. So if we have a iterator, we can so basically we have a function that returns an iterator, and we can use this iterator inside the for of loop, and it will just iterate over. And the ugly thing about writing iterators on your own is that you have to manage the state of the iterator on your own. So if you have a look, it has a closure, and it's closing over the iteration count variable. So you can write iterators on your own, but it doesn't make any sense, too much sense, unless you have to. So there is another concept called generators. So generator functions that were also introduced in ECMAScript ES6. So a generator is a pausable function. So what does it mean? When you execute a generator function, it can be paused, then it can be resumed at a later time, and it has an ability to pass values to and from the function at each point where it was paused. And calling a generator function automatically returns an iterator object that drives the execution of the generator function. So I said that the generating function can be paused, resumed, and so on, but so at first glance, it seems that it breaks the rule of run to completion that we talked on the first slide, but basically this is just an illusion. So under the hood, there is a state machine and so on. So basically it's just a very nice language, syntactic sugar. So let's create a generator function. So we have a generator function created with a special syntax. It's function star. So we have a generator function called sayGreeting, and we are using a yield keyword. So yield keyword will pause the function execution, and it will return or yield the value to the from the iterator to the calling code. So yield hello, it's gonna return an object with a value hello and done set to false. So that's the first thing. Another thing, calling next on the iterator, like in line number 11, with this next function, you can pass values back to the generator function. So it's like a two-way communication mechanism. Yeah, and the next method on the iterator, I already told it, so it returns an object with two values, with two properties, value and done. So once again, sayGreetings is a generator function. On line number 9, we call generator function, and we receive an iterator, and we can call next, 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 and basically it will pause and resume the generator function on the yield statements. So this is a comparison. So on the left, in the left box, we see the iterator that we wrote on our own, and on the right-hand side, this is a iterator. It's too small, but I will scroll it. So this is the same iterator, but written using a generator function. So basically, we are just yielding the values outside. So a few lines after, we can use the same loop. For of loop, we are calling the generator function that creates an iterator, and the for of loop is responsible for calling next, 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 and checking the done flag. So in general, you might wonder why I'm showing you such a weird features of the language. At the first glance, it looks weird, but if you think about it, this yield next communication scheme is pretty similar to promises offers with callbacks. So let's try to write a piece of code that is yielding promises. So we have a function, a generator function, some code, and we are yielding promises. So we are yielding promise 1, promise 2, and then we are computing the result. So if we have a look, that looks pretty much the same like the code snippet from the previous slide, when we were just wondering if it's possible to get rid of the promises and just write a synchronous looking code. So it's pretty much the same. The only thing that we need is an additional function called assistant that will drive the execution of our generator function. So we create in line number 1 an iterator. We pass the iterator to assistant, and let's have a look what is happening. So basically, in line number 3, we are calling the next on the iterator. This next will return a promise. So our next is a promise inside the value. Then we are saying when the promise resolves, we want to go to the next statement. So we go to the next statement, we are calling iterator next once again. So we go back to the generator function, we move to the line number 3, and so on and so on. So basically this assistant function is just responsible for automatically subscribing to promise resolution. Yeah, but it's still pretty complicated, right? But in a few slides, you will see how JavaScript new language feature async await makes it even easier. So to summarize promises, they give us synchronously like looking code and resolve the callback issues hell. And with generators, we can do even more. We just write asynchronous code using the assistant function. Some examples on the web. So long time ago, there was a NPM package called co. So before new language features like async await appeared, and that was a very popular library that provided you this assistant function. And currently, there is one library I know that is using the generators extensively. It's called Redux Saga. So I think on the next lectures, you will learn React. And if some of you will use Redux, then probably, or maybe you will use the Saga as well. So you will see how they are using the generators. So we are almost at the end of the journey. So async await. So the guy is finally smiling. So it should be something pretty easy. So once again, promises gave us a nicer experience than callbacks. Generators enabled us to write synchronous looking code with the help of yield and assistant function. But what if the language itself could provide us this abstraction for the yield and assistant function? Is it possible? And basically, it's already there. It's called async await functions. So it was introduced in with ES 2017. Currently, the browser support is 93%. And basically what it does, it provides us the abstraction over this assistant function. But under the hood, it's using generators. So you can have a look. So the bubble basically is a transpiler that transpiles your code if the browser doesn't support it. So basically you can see that this async await feature is being compiled to pretty nasty piece of code. And just looking at the names, you can see that we have like async to generator, async generator step, and there is a state machine. So basically, even though this code looks synchronous, under the hood, there are some promises being used and generator functions. So going back to our previous example, so we had this function SomeCode. That was generator function. We were yielding promises and calling the assistant function. So now with async await function, we don't need to do it. We just prefix the function with async keyword, and then we can use await on the lines that deal with promises. And basically the await will just block the execution of the function until the promise is resolved or rejected. Okay, so step-by-step syntax introduction. So you have to create an asynchronous function. So you do it by using the async keyword, like in line number 2. And if you have async function, you can use await inside. If you won't mark the function as async and use the await inside, you will get an error. So this is the first step that is required to create an asynchronous function. So when you await a promise, like in line number 5, the function is paused in a non-blocking wait until the promise settles. So even though it looks like the execution will hang on the line number 5, under the hood the promises are being used, so your whole application will be able to respond to button clicks, scrolling events, and all other events. So it's just the illusion that the function is stopping here and waiting. So if the promise fulfills, you will get the value back. So fulfilled value will hold the value. But if the promise rejects, the execution flow will go into the catch block. One additional thing, so await operator works on both promises and non-promises. So sometimes you can call a function and await it. So if this function doesn't return a promise, it won't break your code. So await is like clever enough to convert non-promise values into the promise anyway. And also every async function returns a promise. It can be explicitly with a return statement or implicitly. So if you don't return anything, it will still return a promise. It's something similar with like with promise then API. So even if you don't return anything from then callback, it will still create a promise for you. So just to summarize, when can you use async functions? So pretty much in all the possible ways to create a function. So you can use async await in function declaration. You can use it in function expression inside with arrow functions or with class methods. So you can pretty much use it everywhere. and it works with try catch already mentioned. So yeah, it seems pretty easy so far. So let's complicate things. So async await in loops. So actually, I made the bug similar to this one not so long time ago, but let's just continue. I will tell you about the bug. So when you are using async await with regular for loop or for off loop, it works pretty much as expected and as you read the code. So things are happening sequentially. So here we are executing the function. We have just array. We are using await on the promise resolve. So basically we don't have any real asynchronous action, but this is still a promise. So we are awaiting the promise and we are displaying the result. So if you execute this code and see the console log, so you will see that line number 14 executes first, and then line number 3, then console logs from the iteration, then console log end, and we go higher in the call stack and execute after loop sample call. So this code is synchronous, like it uses promises under the hood, but each line will be executed after the previous one has completed or was resolved. But sometimes this can be bad. So sometimes you can create suboptimal solutions. So use async await with for loops only if the order of execution matters, or where you are concerned about the result of the promises. So those are the cases that you definitely need to use regular for loop. Yeah, so for each, so that was the bug that I did recently. So basically I was iterating over and I was thinking the code is synchronous. So at first glance, it looks pretty similar to the previous example. So we are logging before, call, start, and after. But because for each loop isn't aware that the function returns a promise, it will just execute the callback and return. So this is why the console log statements that are printing the promise results are at the very end. So use this pattern only when you are, not concerned about the order of execution, or you are not interested in handling the results of the promise, because it will like spin up asynchronous actions immediately without waiting for other code. So it's going to be non-blocking completely. So map function with async await is perfect for optimization. So it's like the best of two worlds of for each and regular loop. So in line number 11, so once again, we are creating an array of promises, but this time we are doing it with a map. So basically map executes the async function, and the map callback is returning a promise. So then as a result of a mapping operation, you will get an array of promises. So you can pass this array of promises to the promise.all, and you can proceed with processing once all the promises are resolved. So this is like a nice example that shows we have an async function that just delays the execution of the fulfillment of the promise by 2 seconds. And even though we are running those operations in a loop, the whole execution took 2 seconds and 6 milliseconds. And this is because we are first mapping and creating the promises, and promises are eager. So the set timeout, which is on the line 4, will start immediately, but processing of the results is happening only once all the promises are resolved. Yeah, so using a map with the promise all and for each, that's the like almost silver bullet in majority of cases. So another 2 functions that you will often find and in functional programming and, for instance, on arrays are filter and find, and those functions just do not work with async await functions, so never use them. This is because the filter and find callbacks are always returning promises. Those promises are always truthy, so you will never get what you want from the filter or find, because always the first iteration will return a truthy element. In case of find and in case of filter, you will just get the same array in the result. So don't use filter nor find with async await. So error handling, because async functions return a promise, you can still use then on the result of an async function. So it's like line number 7 on the first code snippet, but also regular try catch will work. So you can choose one of the 2 approaches. Just one thing to be to remember is that there's a difference between returning a promise from async functions and awaiting a promise. Because if you do something like this, so here on line number 3, you are returning a promise, and then you are calling the function which is returning a promise. It is the await keyword which is responsible for throwing the error. So if you don't use the await, the will throw will indeed return a rejected promise, but it's just gonna be ignored. No code will throw an error. So you will need to use the await, and the await is responsible for throwing the error and passing it down to the catch. So remember, always use then or await. So async iterators. So probably you thought that once we have async await, we don't need to use iterators, generators, and so on. But there is a last interesting case that sometimes is useful, and those are async iterators. So as you saw, sometimes we have a situation where we have an array of promises. And what if we would like to just simply iterate over the array of promises without async awaiting? So the solution is async generators and async iterators, and a new loop which is called for await loop. So what is async generator? So without talking too much, it's already like almost 2 hours. So async generator is like a regular generator, but you add an async keyword before it, and it will always yield a promise. So that's the main difference. And async generators are creating async iterators, So, and the difference is still the same. So async iterator has the next function, the next method that will always return a promise. Yeah, so async iterators are normal iterators, but their next call returns a promise. So once again, we have a function star, which is generator. We add async, and then we can use await and yield keywords. And yield, even though you are yielding a regular value, which is a string, it will under the hood create a promise for it. So having that in mind, if we have async iterator, which will produce promises on every next call, then we can use a new syntax, which is called for await loop. So we pass an async iterator, and this async iterator will get the promise from the generator function. It will wait until the promise is resolved. And once it's resolved, it will execute the loop body. So you don't have to do async await on your own. So that's the example that demonstrates the difference between the regular iterator and async iterator. So in line number 19, if you iterate without async keyword over the array of promises, you will be just logging out the promises. But on line number 24, we are using for await loop. We are iterating over exactly the same promise array, and we are getting the promise. We are getting the values that the promise held, which in our case it was just 1, 2, 3 static values. Yeah, and that's just yet another example. So you can create a asynchronous generator that will infinitely generate random numbers after some conditions. So that's something you can have a look later. So sometimes this thing is pretty useful, probably more useful in backend programming with Node.js when you are dealing with streams. So keep it in mind. So async await traps. So sometimes I also catch myself with this. So don't go too sequential. So it's this async await syntax is pretty awesome, pretty readable. So you tend to use it on every line where you are using promises, like await, promise, do something, await, promise, do something. If you do something like this, then the thing that came to my mind is like a boiling one egg at a time. So you put one egg, when it's boiled, you take it out and you put a second one into the pot. So that's the trap with async await. So this is it's demonstrated with the lines 2 to 5. So you await something, then you do the task, and so on. So instead, you can create promises first. So line number 8 and 9 will create the promises, then you await. So, and promises are eager once again, so they will start doing their job. On line number 11, you await the completion, so resolution of the promise, you do the task. And on line number 13, you await the second one. And you also, of course, can do the same with promised at all. So just remember, just don't get too sequential. Yeah, that's yet another example of the same thing. So two exactly the same things can be done more or less concurrently if you create promises first and then await for them, or you can do one first and the second one later, which is not optimal. Async await summary. So just like previously, we came from the callback hell to the promises land, which was then and catch one after another. Then now, thanks to the async await, we came from the promises land to the async await land. So it's even it looks even better. So a few sentences about observables, because this topic deserves its own presentation, I guess. So there are a few issues with observables as well. So promise can be resolved only once, and they don't fit well into the scenarios when we are dealing with events that are like a stream of events. So button clicks. So if you use promise for that, you can resolve the promise only once. So it doesn't suit well. So for instance, we had this after delay wrapper for set timeout API. If we do the same for the set interval, it doesn't work because will resolve the promise only once. So it doesn't make any sense. So most of our UI apps are dealing with stream of events. We have mouse clicks, resizing, WebSocket communication, asynchronous JavaScript, and so on. So if we think about those events as asynchronous data streams, we can apply something which is called reactive programming. And there is a really cool library for that. So it's called Reactive Extensions for JavaScript, RxJS. And one note, so far we were discussing things like promises, callbacks, async await that are built into the browser. So you don't need any library in order to use them. But with observables, it's not the case. So observables and so basically the observables are not built into the browser. So you need a library for that. And this is what RxJS does. So in reactive programming, we have a source and a source or producer. So things that are producing the events. So like I said, like a button clicks, server-side events, stock exchange, price change values, and so on. Then we can, and the source of those events, we call it observable. And you can think of the observable like a never-ending array. Then in reactive programming, you usually do some kind of transformation on the events. And those transformations are called operators. And at the very end, there is a consumer of the event. And this is a callback function registered with the subscribe method. And usually in reactive programming, you have to before implementing some solution, you have to think reactively about the events. So let's say we have a drag and drop problem that we want to implement. So for this case, you will break down this problem into this sentence. After mouse down event occurs on the element, I want to react to the mouse event on the document, on the mouse move on the document, until mouse up event occurs on the document. After mouse up, I update the element's position. So if you read this sentence really slowly, I'm in the rush because it's almost 9. You will see that you have a set of events that are happening. So like mouse up, mouse down, mouse move. You have a producer of the events, so like a document or an element that you want to drag. You have transformations, so you will need to change the position of the element that was dragged. And you have conditions, so after and until. So how does it compare to promises? So so far with promises, callbacks, async await, in most of the examples, we were dealing with single or maybe 2 sources of asynchronicity. With RxJS, you can do the same things, but in a more complex scenarios using operators like concat, merge, switch map, so you can have multiple sources of events and transform them or merge them. So basically the catalog of operators is like countless. And use cases, so coordinating asynchronous tasks, rate limiting, composing events together, and probably some of you will do React or Angular tasks as well. So reactive extensions, RxJS, are often used in Angular world. So you will see the observables there pretty often. But also in the React, there is a library called MobX, for instance, that uses reactive extensions. So the bottom line is that reactive programming is just a way of solving complex asynchronous data streams problems. So one last slide. So like with floats, flexbox, CSS grid, there is no silver bullet. So mix those different techniques, callbacks, promises, async await, RxJS, and for different problems, there are definitely different tools you should use. So callbacks for simple event handling, async await for promise-based asynchronous data flow. If you want more control, then use promise API like all raise, async generators for more advanced scenarios, probably on the backend more often, and reactive programming for reactive streams. So it's almost 9 o'clock. So once again, very long lecture. Sorry for that, but that's it. Thanks for your attention. I will put the slides on the Discord channel soon. Does anybody have any questions? Okay, let me just, okay, so Maciek is asking about Rx, are we planning to have a webinars about RxJS and React sagas? So quite frankly, I don't know. I didn't see those, but RxJS probably should be handled to some extent. We're doing Angular, because this is like a thing which is used all over the place with Angular. Okay, Pavel, read the comments after lecture. Sorry for that. So reading right now. So I'm scrolling slowly. Okay. So there was a question about promise executor. No idea if this is valid, but I will try. So there was one question about the promise executor function. So line number 2 here is just a name used in the documentation. So it's just a It's just a callback function. So when you create a promise, you provide a executor function. And here in lines 5 to 11, this is the body of the executor function. And this executor function just receives resolve and reject callbacks that you can use to resolve or reject the promise. So at the very beginning, there was one comment about without the same time frame. Yeah, probably a typo somewhere in the presentation. I will try to find it later. Okay, scrolling down. Okay, so I guess no more questions. So thanks for your attention and good luck with the home task.